Hello everyone. Today we are going to be looking at the Linux Fundamentals module uh, on Hack the Box, and yeah, it's basic stuff. It's marked as fundamental. It says it's going to take 6 hours, but we're going to power through it. Hopefully, get it done less time than that. And yeah, Linux structure using the shell, navigating the operating system, working with files and directories, admin, service management, and permissions management. So pretty basic stuff. Hopefully I know most of it already. Actually, that's a lie. I probably know about 3/4 of it. So I'm sure there's going to be stuff that I don't know. It's always worth going over basic courses, because you often learn things, little things that will help. So um, yeah, let's jump straight into it. Let's go. Okay. So yeah, I'm gonna do the reading because, as I said, who can be bothered to read? Especially a lot of people have dyslexia. A lot of people just can't be bothered. So sometimes it's useful just to hear some guy on the internet talk it out. So okay, let's read. Many events led up to creating the first Linux kernel and ultimately the Linux operating system, starting with the Unix operating systems released by Ken Thompson and Dennis Ritchie, who both worked for AT&T at the time in 1970. The Berkeley software distribution BSD was released in 77, but since it contained the Unix code owned by AT&T, a resulting lawsuit limited the development of BSD. Richard Stallman started the GNU project in 1983. His goal was to create a free Unix-like operating system, and part of his work resulted in the GNU, the General Public License (GPL), being created. Projects by others over the years failed to result in a working free kernel that would become widely adopted until the creation of the Linux kernel. At first, Linux was a personal project started in 91 by a Finnish student named Linus Torvalds. His goal was to create a new free operating system kernel. Over the years, the Linux kernel has gone from a small number of files written in C under licensing that prohibited commercial distribution to the latest version with over 23 million source code lines, comments excluded, licensed under the GNU General Public License version 2. Linux is available in over 600 distributions or an operating system based on the Linux kernel and supporting software and libraries. Some of the most popular and well known being Ubuntu, Debian, Fedora, I don't know how to say this, OpenSUSE, I think it's OpenSUSE, Elementary, Manjaro, Gentoo Linux, Red Hat, and Linux Mint. Linux is generally considered more secure than other operating systems, and while it has had many kernel vulnerabilities in the past, it is becoming less and less frequent. Is less susceptible to malware than Windows operating systems and is very frequently updated. Linux is also very stable and generally affords very high performance to the end user. However, it can be more difficult for beginners and does not have as many hardware drivers as Windows. Since Linux is free and open source, the source code can be modified and distributed commercially or non commercially by anyone. Linux-based operating systems run on servers, mainframes, desktops, embedded systems such as routers, televisions, video games, consoles, and more. The overall Android operating system that runs on smartphones and tablets is based on the Linux kernel, and because of this, Linux is the most widely installed operating system. Linux is an operating system like Windows, iOS, Android, or macOS. An OS is software that manages all of the hardware resources associated with our computer. That means that an OS manages the whole communication between software and hardware. Also, there exists many different distributions, distros. It is like a version of the Windows operating system. With the interactive instances, we get access to the Pwnbox, a customized version of Parrot OS. This will be the primary OS we will work with. We've seen this all. It's a Debian-based Linux distribution focused on security, privacy, and development. Okay, so it's got some philosophy things we'll read in a sec. I'm currently drinking boiled water because it's late at night. I've already brushed my teeth and I would rather be having tea, but boiled water will have to do. So, yeah, I mainly use Windows, I'll be honest, because I've no other need to. But I've touched on Linux stuff. I've used Linux before, so I know some of this stuff. We'll see. Philosophy. Linux follows 5 core principles. Principle 1. Everything is a file. Description. All configuration files for the various services running on the Linux operating system are stored in one or more text files. Number 2. Small single-purpose programs. Linux offers many different tools that we will work with, which can be combined to work together. 3. Ability to chain programs together to perform complex tasks. The integration and combination of different tools enables us to carry out many large and complex tasks, such as processing or filtering specific data results. You see this with piping and redirecting, things like that. Number 4, avoid captive user interfaces. Linux is designed to work mainly with a shell or terminal, which gives the user greater control over the operating system. Okay. 5, configuration data stored in a text file. An example of such a file is the etc password file, which stores all users registered on the system. Cool. Okay. Components. The bootloader, a piece of code that runs to guide the booting process to start the operating system. Parrot Linux uses the grub bootloader. The OS kernel. The kernel is the main component of an operating system. It manages the resources for systems I/O devices at the hardware level. Daemons. Background services called daemons in Linux. Their purpose is to ensure that key functions such as scheduling, printing, multimedia are working correctly. These small programs load after we booted or log into the computer. The shell. The operating system shell, or the command language interpreter, also known as the command line, is the interface between the OS and the user. This interface allows the user to tell the OS what to do. The most commonly used shells are Bash. That's the only one I've heard of it. TCSH, CSH, never heard of. KSH, ZSH, I've heard of. And Fish. Okay, I think I've heard of Fish. Anyway, graphics server. This provides a graphical subsystem server called X or Xserver that allows graphical programs to run locally or remotely on the X windowing system. Window Manager, also known as a graphical user interface, a GUI. There are many options, including GNOME, KDE, Mate, Unity, and Cinnamon. A desktop environment usually has several applications, including file and web browsers. These allow the user to access and manage the essential and frequently accessed features and services of an operating system. Utilities. Applications or utilities are programs that perform particular functions for the user or another program. Cool. Linux architecture. I always want to say Linux, but it's not. It's not Linux. It's Linux. Linux architecture. Linux operating system can be broken down into layers. Hardware, so peripheral devices such as the system's RAM, hard drive, CPU, and others. The kernel. We've discussed this already, but it's the core of the Linux operating system. Its function is to virtualize and control common computer hardware resources like CPU, allocated memory, access data, and others. The kernel gives each process its own virtual resources, prevents and mitigates conflicts between different processes. The shell, also known as the CLI, we've discussed. System utility makes available to use all the operating system's functionality. Okay, file system hierarchy. The Linux operating system is structured in a tree-like hierarchy and is documented in the file system hierarchy standard. Linux is structured with the following standard top-level directories. Okay, this is something that's quite useful to know. Bin, boot, dev, etc. Blah, 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 blah. Okay. Okay, wow, these are useful. We'll read these out. Okay, so the root, that's known as root. Top level directory is the root file system and contains all of the files required to boot the operating system before other file systems are mounted, as well as the files required to boot the other file systems. After boot, all of the other file systems are mounted at standard mount points as subdirectories of the root. Bin contains essential command binaries. Boot consists of the static bootloader, kernel executable, and files required to boot the Linux OS. See, some of this stuff I actually don't know. I didn't know the static. I don't know what boot is, to be honest. Anyway, dev contains device files to facilitate access to every hardware device attached to the system. Cool. etc, local system configuration files. Configuration files for installed applications may be saved here as well. Okay. Home, each user on the system has a subdirectory here for storage. Lib, shared library files that are required for system boot. Media, external removable media, devices such as USB drives mounted here. Mount, temporary mount point for regular file systems. OPT, optional files, optional files such as third-party tools can be saved here. Root, the home directory for the root user. SBIN, the directory contains executables used for system administration, binary system files. Okay. Temp, operating system, and many programs use this directory to store temporary files. This directory is generally cleared upon system boot and may be deleted at other times without any warning. User contains executables, libraries, man files, etc. And var. This directory contains variable data files such as log files, email inboxes, web application related files, cron files, and more. Cool. Okay. Cool. Let's read this all. It's crucial to learn how to use Linux shell. We'll skim read it. They're often used for Linux is less error prone as opposed to Windows servers. For example, web servers are often based in Linux. Okay, cool. That's the shell. We know what shell is. Terminal emulators. Terminal emulation is software that emulates the function of a terminal. It allows the use of text-based programs within a graphical user interface. Many different terminal emulators exist, such as GNOME Terminal, XFCE4 Terminal, Xterm, and many others. Also, so-called command line interfaces that run as additional terminals in one terminal and thus are multiplexers. Okay, cool. These multiplexers include tmux, GNU Screen, and others. In short, a terminal serves as an interface to the shell interpreter. Terminal emulators and multiplexers are beneficial extensions for the terminal. They provide us with different methods and functions to work with the terminal, such as splitting the terminal in one window, working in multiple directories, creating different workspaces, and much more. Examples of the use of such a multiplexer called tmux could look something like this. Okay, so okay. I'm actually honestly. So, what's the difference between a terminal and a shell? It's a really stupid question, but sorry, there is no difference. Terminal and shell. I mean, I think there is actually a technical difference, but anyway, yeah, okay. The most commonly used shell is the Born Again shell, Bash, and it's part of the GNU project. Everything we do through the GUI we can do with the shell. The shell gives us many more possibilities to interact with programs and processes to get information faster. Besides, many processes can be easily automated with smaller or larger scripts that make manual work much easier. Besides Bash, there also exists other shells like TCS, blah blah, KSH, ZSH, Fish, and other ones. Cool. Bash prompt is easy to understand, includes information such as username, the host name, and current working directory. The format can look something like that. Home directory for a user is marked with a tilde, and the default folder when we log in. $sign stands for a user. As soon as we log in as root, the character changes to hash. Cool. Looks like that. $user hash is root. We see here the same as when we worked in the Windows GUI. We logged in as a user on the computer with a specific name, and we know which directory we are in when we navigate through our system. Bash prompt can be customized and changed to our own needs. The adjustment of the bash prompt is outside the scope for this module. However, we look at the bash RC generator and power line, which gives us the possibility to adapt our prompt to our needs. Okay. Cool. Getting help. We will always stumble across tools whose optional parameters we do not know from memory or tools we have never seen before. Therefore, it's vital to know how we can help familiarize ourselves with these tools. The first two ways are the man pages and the help functions. It's always a good idea to familiarize ourselves with the tool we want to try first. We will always learn some possible tricks for some of the tools that we thought were not possible. In the man pages, we will find the detailed manuals with different explanations. Okay, so curl is a tool to transfer data from or to a server using one of the supported protocols. Cool. Offers a busload of useful tricks like proxy support, user authentication, FTP upload, HTTP post SSL connections. Good lord. I haven't really used curl that much. As we will see below, the number of features will make our heads spin. Curl is powered by libcurl. Cool. After looking at some examples, we can also quickly look at the optional parameters without browsing through the complete documentation. We have several ways to do that. So you just do --help after. And you can see in the snippet, there's just a bunch of different things. Basic, use HTTP basic authentication. Can also, I'd like to learn how to use curl because I've seen it used by some people I know, and I think it's probably quite a useful thing to know. Okay, tool -h. You can also do -h as well, same thing. As we can see, the results from each other do not differ in this example. Another tool that would become useful in the beginning is Apropos. Each man page has a short description available within it. This tool searches descriptions for instances of a given keyword. Apropos keyword, apropos sudo. Execute command as another sudo, sorry. Execute command as another user. Configuration, sudo plugin API. God lord. Default sudo security plugin policy. Other useful resources is, if we have issues, then a long command is explainshell.com. Write down the command line to see the help text that matches each argument. What's that? Okay. Okay, interesting. Huh. So that's an interesting website. Switched it to dark theme. Ooh, that's nice. I should prefer light theme for now. If a command is terminated by the control operator ampersand, the shell executes the command in the background. In a subshell, the shell does not wait for the command to finish and the return status is 0. Commands separated by a semicolon are executed sequentially. The shell waits for each command to terminate in turn. The return status is the exit status of the last command executed. Didn't know that. Pipeline will come across. What is this one? This is just... God knows. Explain shell. So... Oh, really is... This is quite nice. You can just give it a whole... You see something online or whatever, a huge, long thing that will break it down for you. Very nice. GNU version of the tar archiving. So these are all the options. tar1, ZSO some directory. Very nice. It actually gives all the information as well. Yeah. Very nice. It's a nice website. Mark complete. Okay. System information. Is there a this is all useful stuff. There's some questions here. Fantastic. Okay, this is going to go into the meat of it. Before that, I have to take a sip from my water. This is probably going to take two videos, I'd say. Where are we for time? We are about 20 minutes in, 17 minutes in. Since we will be working with many different Linux systems, we need to learn the structure and the information about the system, its processes, network configurations, users directories, user settings, and the corresponding parameters. Here's a list of the necessary tools that will help us get the above information. Most of them are installed by default. Who am I? Displays the current username. ID returns user's identity. Hostname sets or prints the name of the current host system. Uname prints basic information about the operating system name and the system hardware. PWD, print working directory. ifconfig is used to assign or to view an address to a network interface and or configure network interface parameters. IP is a utility to show or manipulate routing, network devices, interfaces, and tunnels. Netstat shows network status, whatever. SS, another utility to investigate sockets. PS shows process status. Who displays who is logged in. Env prints environment or sets and executes command. LSBLK lists block devices. LSUSB devices. LSOF open files. LSPCI PCI devices. Okay, well, print the name of the computer that we're logged into. Okay, who am I? Current username. Figuring out what user we're running on. Situational awareness. From there, we can figure out if the user has any special privileges. Cool. ID command expands on the who am I command and prints out our effective group membership and IDs. This can be of interest to penetration testers looking to see what access a user may have and sysadmins looking to audit account permissions and group membership. And this output, the Hack the Box group, is of interest because it is non-standard. The ADM group, okay, so what we've got here, administrator group means the user can read log files in file log and potentially gain access to sensitive information. Membership in the sudo group is of particular interest as this means our user can run some or all commands as the all-powerful root user. Sudo rights could help us escalate to what is going on. Something just crashed. Consider encoding failed. OBS had a little heart attack there. Hopefully it's still recording. Yep, just said encoding failed and had a heart attack, but whatever. Okay. ADM group means the user can read log files, blah, blah, blah. Sudo group, particular interest of us. Sudo rights could help us escalate privileges or could be assigned to a sysadmin that they may need to audit permissions and group memberships to remove any access that is not required for a given user to carry out their day-to-day tasks. ID, okay. Yeah, you got the user ID, the name, GID, okay. Groups. I don't know what the numbers are. I guess they're just the IDs. They're just the IDs of the group. So it's like we are cryo T3, whatever it is, part of this GID. Oh no, that's the group ID. I don't know what GID is. But we are in these groups. I was in. I know these are the different groups. Does it say which group we're in? Or just we are in? I don't know. We're in that group. Yeah. This output the hat the box group is of interest because it's non-standard. ADM group means the user can read log files. Shipment IDs. These are the groups we're in. So we're in hack the box group, we're in ADM group, CD-ROM, sudo, dip, plug dev, admin. I think that's all that means. And yeah, these are just three things that are kind of relevant. You've got the user ID, group ID, and I'm not sure exactly what that tells me, but whatever. Anyway, uname. Let's dig into the uname command before. If we type man uname, it will bring up the man page, which will show us the possible options you can run with this command. Print system information. Okay. Uname-a. Print all information in the following order, except emit-p and -i if unknown. Okay. Kernel name, the node name, kernel release, kernel version, machine, processor, hardware platform. Okay. Sudo uname-e, Linux box. Wow, okay. Cool. Kernel name, kernel version, node name, network name, network, host name. Okay. Kernel name is Linux, the host name is box. The kernel release is 4.15, generic kernel version. Okay, uname to obtain the kernel release. Suppose you want to print out the kernel release to search for potential kernel exploits quickly, as we saw with the Metasploit videos. Yeah. We can type uname-r to obtain this information. Cool. Potential kernel exploits. With this info, we could go and search 4.14509 generic exploit, and the first result immediately appears useful to us. Yeah, exploit DB. You saw this beforehand. Awesome. Highly recommended to study the commands and understand what they're for and what information they can provide. They're a bit tedious. We can learn much from studying the man pages for common commands. We may even find out things we didn't even know were possible with a given command. This information is not only useful for working with Linux. It's not only used for working with Linux. However, it will also be used later to discover vulnerabilities and misconfigurations of the Linux system that may contribute to privilege escalation. Here are a few optional exercises that we can solve for practice purposes, which will help us become familiar with some of the commands. Okay, logging in via SSH, like everyone knows how to do this. This is just really, really basic. Okay, SSH, well, we'll do it anyway. Start instance. Instance is starting. And we spawn a target. Find out the machine hardware name and SSH. We have to SSH to la-da-da. So let's quickly go full screen. Cool. Close that. And when that's spawned, we need to SSH into it. So Just quickly read it. SSH Secure Shell refers to a protocol that allows clients to access and execute commands or actions on remote computers on Linux-based hosts and servers running on another Unix-like operating system. SSH is one of the permanently installed standard tools and is the preferred choice for many administrators to configure and maintain a computer through remote access. It is an older and very proven protocol that does not require a GUI. For this reason, it works very efficiently and occupies very few resources. We use this type of connection in the following sections and in most of the other modules to allow the possibility to try out the learn commands and actions in a safe environment. We can connect to our targets with the following command. SSH username at IP address. Awesome. Okay, so we've got that. So you just do that. Yep. So let's open a bash shell. So you do SSH. What was the username? SSH username. HTTP student. HTTP student at that. Let's do it. Am I being stupid, or is that that doesn't feel right? I feel like we've done something terribly wrong. Name or service not found, not known. Eh? Maybe just do that. Cannot resolve. Yeah, this doesn't feel right. Maybe don't you just want to do that? Yeah. Okay. Are you sure it's configure correct? Yes. Yes. Permanently added. Password is Hack the Box Academy blah blah blah. That one. Paste. Enter. Permission denied. Did not like it. Let's try and type it out. Are we mucking this up? Oh, okay. I think we may already be mucking this up. That's a bit embarrassing. Oh, okay. I'm mucking this up. I know how exactly I'm mucking this up. SSH HTTP student at. I think I put a space in there for some stupid reason, which is not the correct thing to be doing. There we go. There we go. And yeah, let's copy that. Paste. And it should work. It doesn't show automatically. I think you can change that, but it does try and hide it for security's sake. Okay, welcome to Ubuntu 18.0.4 LTS, long-term service, that stands for. Or something, LTS, long-term something, I don't know. System information, system load, memory usage, swap usage, processes. Cool. Okay, canonical life patches available for installation. Reduce system reboots and improve kernel security. Awesome. You can see documentation, management support, and that I think is the kernel version. Cool. Okay. Find out the machine hardware name and submit it as the answer. The machine hardware name. Now, if we go up here, the hardware name. Oh, hardware name. Does it just mean uname? I think it means uname. I think we want to do uname, and we want hardware platform. Maybe it's talking about hardware platform. So uname-i. Uname-i. x86_64. I'm not sure that's what it means, but find the machine hardware name. That's not. It can't be what it's talking about. What's a hardware name? What does that even? Hardware name. What does that even mean? Does it just literally mean? Sorry. does it just mean the host name? Is that literally what we need? Host name. Nix Fund. I think that may be what it means. Oh, hint. Take a look at the options. Oh no, okay, I was wrong. I was right the first time. x86-64. x86-64. Yeah. What is the path to HackTheBox student's home directory? Path. So if we go to the home directory, what we're in the home directory. But if you that's how you get to the home directory, CD, then the tilde, which is if you do shift hash, it's next to the return on my keyboard. So there's hash, and then there's shift hash. What did that? Dum-de-dum, what's the path? So you can just do print looking directory and it will print the path. There's the relative, well, no, it's the absolute path we're on about. Yep. What is the path to HackTheBox's HTTP students mail? The mail, sorry. What? Students mail. Oh god. Was it in var? Scheisse. Let's see where we are. Let's see what we've got here. Nothing in here. Okay. Anyway, we don't need to be there. Let's go to the root. Let's go in here. So the mail is mail. Let's not waste any time. Let's just go quickly double check what we can see. God, was it one of these? Mail. So the mail was email inboxes was there. Is it in there? Is that what it means? Good lord. Under var. Is that what they want? Okay. Change directory to var. And then see, look what's in here. And then there's mail. Change direction to mail. And let's see what's in here. Dash-A, so there's nothing in here, but it is. We can just do print working directory, and it's there. Var mail, I think that's what we want. Oh dear. Oh dearie me. What is the path to students' mail? I don't know what it means by that. Sorry. I'm going to quickly pause and Google. Okay, I think it actually is under this var spool. So let's do that. Let's quickly have a check. So let's do that. Var spool mail. Var spool mail. Let's go. Okay. Okay, I see. I see we're in the wrong. We are in the wrong. That is sad. Sadness. I don't really know. I don't really know about that. Whatever. Anyway, which shell is specified for? Wait. Maybe it's because that's under root. We need to be under home. Let me pause again. I don't need to pause. Let's just do it. Change directory to home. Oh no, there was nothing in here. What am I doing? Okay. There's nothing in here. I don't know. Whatever. Not important. Which shell is specified for the student user? Which shell is specified? It's clearly bash. Is it not? Is it not? Is it not? Is there a command to tell you, or is it just literally just it's bash? Fudge. Which shell is specified? Let me pause. Okay, apparently to find the shell you have in the default environment, you can check with echo $shell. So echo $shell bash. There you go. What am I doing wrong here? Oh gosh. Let's quickly just try this one. See if it does anything different. Bash, yeah, that's the process. It's bash. Why are you telling me it's wrong? Okay, whatever. I don't know, let's try ZSH then. It's clearly bash, but like, whatever. Why are you being like this? Why are you being like this? Bash with a capital B? No, okay, whatever. Which kernel version is installed in the system of format? Okay, blah de blah de blah. So that's literally what they said up here. Kernel version -v. Yeah, you want to do uname -v. It's gone small again. I don't like the fact that it does that, but we'll live with it. Uname -v, and the kernel version is #126 Ubuntu blah 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 blah. Okay, all this. Copy that. Format. That's gonna be wrong. Okay, format 1223. Well, that's not the living kernel version, is it? Oh god. I think I'm going mad. I think I am actually going mad. 9:40:11. Is that the time? No, that's not the time. That is the time. Sorry. No. Clearly that is not the right thing. Uname R. I think that's actually what we want. It's clearly uname -R. Yeah, there we go. That's actually what we want. 4.1 0. 4.15.0. What a mess. What is this? This must be like when it was installed or something. I don't know. At 9:40 or Wednesday, October the 21st. I don't know. 2020. Anyway, that's the answer. What is the name of the network interface that MTU is set to 1500? Ugh. Max transfer unit or something? Max transfer something? Name of the network interface. So, if you look at this. ifconfig is for mucking around with network interfaces. So ifconfig, and it's going to give us two different interfaces, ENS192 and low for something which I can't remember actually. Loopback running MTU. This one MTU 1500 MTU networking. I want to see if I was right. I bet it's the max transmission unit. It's not there you go. It's a measurement representing the largest data packet that a network connected device would accept. Cool. Data is either fragmented into smaller frames or dropped. Historically, Ethernet has a maximum frame size of 1500 bytes. Ethernet package larger than 1500 bytes is called a jumbo frame. Cool. You got a bunch of different information here. iNet to netmask broadcast, iNet 6. Dead beef. What? RX packet says RX is okay. We'll go into what all this means. Maybe I need to do a little bit of research. I think I know what's going on. But anyway, yeah. What was the answer? ENS192, I think, is the answer to that one. Scroll down, scroll down. ENS192. Okay, which ones did we get? Which shell is specified? It's clearly bash. I don't know why that's not working. And yeah, what's the path to the... Wait, did we not get that? What? Sorry? How is that not right? How do we not get that common? That's ridiculous. Am I going crazy? It's too late. What's the path to the student's home directory? Is that not the student's home directory? Have I gone crazy? Is it literally just... Okay, I think I'm being stupid, but maybe it's just that. I mean, there seems to be 3 different things. Hack the Box student. I don't know. Come on, it has to be. God. I don't know. Get rid of that. I mean, it's clearly... Maybe if we just get rid of that. Oh, I don't know. You've already answered this question. Okay, whatever. Screw that. Okay, we're going to do this page, and then I think we are... Well, I'm getting tired, so I'm going to call it a night after this page. But user management. User management is an essential part of a Linux admin. Sometimes we need to create new users or add other users to specific groups. Another possibility is to execute commands as a different user. After all, it's not too rare that users of only one specific group have the permissions to view or edit specific files or directories. This in turn allows us to collect more information locally on the machine, which can be very important. Let's take a look at the following example of how to execute code as a different user. Okay. Cat etc shadow. We'll look at etc shadow. etc. I want to say that's like etc. What does etc stand for? What does etc stand for in Linux? Google is the answer to everything. It is literally etc. It's just really editable. It was originally meant for etc, but now it stands for editable text configurations. Seriously, as of 2011. Update might be useful for others. Folder is used for host-specific configurations. Edit configure. What? Oh god. Configuration files. System-wide configuration files. But not all files in etc are configuration files. God, it just looks like a bit of a mess, doesn't it? Anyway. Where are we? Okay, cool, etc. Shadow. As for configuration files. Execution as a root. Okay. Here's a list that will help us to better understand and deal with user management. Sudo su user add creates a new user update, default new user information, user delete, user mod, add group adds a group to the system, and del group removes a group from the system. Password changes user password. User management is essential. Okay, simple stuff. Answer the questions below. Which option needs to be set to create a home directory for a new user using user add command? Oi, 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 oi. Can we refresh this? God damn it. I don't know. User add -- help. So to, what was it? Create a home directory. Good lord. Create home -m. Create the user's home directory. No create home. Do not create the user's home directory. -o non-unique now. Okay. Password, encrypted password, system, create a system account. Skeleton directory. Okay. Cool. Use the extra users database. Some kind of weird stuff. Okay. Alright. That's not name or ID of the primary group. Let's not muck around with this. It's just -m. Great. Okay. -m. Submit. Awesome. Which option needs to be set to lock a user account using the usermod command? Long version of the option. Okay, so do usermod -m. Okay. Have I just? Oh, I've I mucked up. I typed in usermod -m, but it doesn't matter. It's giving us the help anyway. So to lock an account. To lock an account is that lock the user. Okay, actually, I just want to quickly show when you do use -m, it is an option. It means move home, so it'd be move the contents of the home directory to the new location. So we'd actually have to give it a new directory. But there's an important thing to note here is that unlike Windows, Linux will not prevent you from doing anything stupid. So if you're tired and like I am, and you type in a command like that, you know, yeah, if I'd accidentally typed in, I don't know, capital L by mistake, I'd have locked it. So that wouldn't have been great. Yeah. Anyway, but fortunately we would have to provide a new directory, and it's telling us there we need. So we did on -m, but we don't actually have to give a new location or something. So you'd have to do -m -d as well. Anyway, doesn't matter. Okay, lock -l, well, -L, or actually onto the long version, which is just --lock. Cool. --lock. Which option needs to be set to execute a command as a different user using the su command? Su -help. Okay. Which needs to be set to execute as a different user? I'm not sure about that. How about we go to man su, see what happens. Use to become another user during a login session. Yeah, I'd have thought you just do su, then the username. Is that not correct? Okay. Quick note: if you want to go down, you press the J, and the K will go up. Using the kind of Vim-like controls. I love Vim. Really easy to learn actually, but you just learn a few shortcuts, and Vim is kind of installed on basically every Linux system. I'm not sure if it's installed by default, but it is a text editor. Anyway, I'm digressing. What is -C? Treated as command by most command interpreters. Okay, options. Specify command -L provides an environment similar to what the user would expect, how the user logs in directly. Is that one is used? It must be specified before the username. That's S -M. See, the help thing doesn't give all the information you need. And you can configure it as well. Good lord. Oh, we can see what etc shadow is now. Secure user account information. A lot of malware tries to delete this or override it or something. Yeah. etc password, user account information. etc login.defs shadow password suite configuration. Okay. I'm not exactly sure what it's talking about. I think that may be a mistake on their part. Maybe it's talking about sudo. sudo. I don't know, login. But it says login here is provides an environment similar to what the user would expect had the user logged in directly. I mean, I've never used it, but let's try. Okay, no. I'm not exactly sure what that is. There is no. Let's try them all. I mean, there's only 3. -- command. I'm pretty sure you don't need. Okay. Oh, sorry, I can't read. Which option needs to be set to execute a command as a different user? Okay, not just login, a command. Yeah, specify a command that will be invoked by the shell using -c or -- command. The execute command will have no control in terminal. This option cannot be used to execute interactive programs which need controlling TTY. What the hell is a TTY? Terminal something? TTY Linux. Oh no, I'm being dumb again. TTY is a command. To print the file name of the terminal connected. It stands for teletypewriter. Print the file name of the terminal connected to standard input. Okay. What does TTY do? If we just do it. And to quit out of this, by the way, you just press Q, but TTY. Dev. Okay, what on earth? Should we try that? Apropos. TTY? Nothing appropriate. Okay. TTY -- help. Print the file name of the terminal connected to standard input. So the terminal connected to standard input for us is apparently dev.0. Not exactly sure what that means, but whatever. Awesome. Okay, cool. Alright, so we're about halfway. We've got past the basic stuff. A bit less than halfway, actually. The next bit will be talking about package management. Okay, I'm sure we'll be talking about apt. There you go. There's other package managers. There you go. I didn't really. Pip is the Python one I've used. I mean, Git's not a package manager, is it? Can it be used as some sort of package? Well, I guess can you use package. That's not a package manager. I'm sorry. That's not correct. But package management, service and process management is probably quite useful. Working with web services. Curl. Yeah, all this web stuff. wget is. Yeah, I've used that before. Cool. All right. I wonder if it goes over like, yeah, this stuff is actually one of some of these useful stuff. Which find, locate. I don't know that. Where's grep? Seriously, it doesn't go over grep. Come on. Come on, this is basic. Where's grep? And awk and stuff like that. Filter contents maybe. Come on, please. Grep. Okay, we might look at grep in a bit of detail. Don't know if there's. Well, actually, you know what? We'll look at some of these which I'm interested in, and we'll do the questions. But I will look at some of these that I'm interested in and just go into a little bit of detail with them. But it's got a tips and tricks thing here as well, which is quite nice, I guess. Many shortcuts we can use to make working with Linux easier. Cool. Yeah. Search through the command history. Control R. Control L clears the terminal. I didn't know that. Control L, let's do it. Awesome. I like that. Control R. So if we do Control R, reverse search, you can just do, I don't know, what have we typed in? bash or something. No, we didn't do bash. I don't know what was the command we do. Oh, good lord. Okay, T Y. I don't know. Whatever. But yeah, you can also do clear. Command not found. Can you do? You can't do CLS. That's Windows. There's 17 similar ones. Good lord. Sudo -- help. See what? There's so many different things for this. Good lord. Run login show as target user. Gosh. List users privileges. See what that does. Sometimes it's just nice to just play around with them. Sudo -- list of what's the password? I don't know. Can't really bother to go and find it. Anyway, but also look at Linux security. Okay. Snort, Cricket, RK Hunter, and Linus. SE Linux security enhanced Linux. Okay. La-di-da. Okay, anyway, let's go back to where we were. And yeah. Okay, cool. I'm going to stop there, but hopefully this has been at least a little bit informative. Sorry I'm quite tired tonight. Do not forget to like and subscribe if you are one of the about 3 people who have watched my videos. Thank you for watching them. And yeah, I will see you next time. Goodbye.